using a Nexo GOT system divided into 6 hangs, 2 front fill hangs as we call them, smaller ones for the first 15 meters. Then we got delays or main hangs, which is 21 boxes aside, and then we've got the outfills, which is approximately the same as the delays. We also have 4 hangs of DV-DOSCs for the backfills for the audience on the back bleachers. For monitoring we're using Midas XL8, or actually 2 of them. We've got 1 main and 1 backup. We're using about 80-ish channels and 16 in-ear systems from Sennheiser, 2000 system.
Okay, we use Cubase from Steinberg to play back the backing tracks, and this year it's allowed to have different channels, not only stereo channels. So you can also use bass and drums and so on. So we got a better PA mix and a better monitor mix, and so we basically got the drums, bass, guitars and the keys and whatever you want. I think it's 5 different stereo channels plus the backing tracks that we can play, and also hidden tracks for the pitch for the performers.
At front of house we're using another Midas console, the Pro 9. And also there we've got a main console and a backup console. For plugins we're using a Mac computer with Waves plugins. And that's about it out there. Microphones we're using Sennheiser 9000, their new digital system, which works very well. We got 3 batches of 6 handhelds and 3 batches of body packs that alters for the contestants.
This is the first time ever for Eurovision that we're using the new digital 9000 system from Sennheiser, which is a wireless microphone system capable of doing multi-channel in the UHF range. We have some big advantages by using the digital technology. First of all, its audio quality is improved according or compared to some of the older analog stuff. We have some RF specific advantages in this because we are working with very high linearity in all the amplifier stages basically of the system. So intermodulation does not happen, making frequency coordination for large events like this a lot easier, because we don't have to think of mixing products in between the transmitters, but basically only the spacing in between them, and of course the interference sources that is in a grand event like this, because there's quite a lot of noise sources anyway. We have like some of the cameras generate a lot of it. We have some distribution video networks which is using some semi-consumer stuff in there, which actually generates quite a lot of noise in here. So we have to work our way around that, and that just is much easier as we don't have to think about the mixing products of the microphones. On top of that, there's some advantages of using this system. For instance, the antennas are you could call them intelligent. We have two-way communication with them. So whenever we connect an antenna to the receiver, you don't have to think about the cable length you're using and therefore setting your antenna booster gain. It simply calibrates by itself. The selectivity in the antenna is placed directly after the passive antenna element and before any amplification, meaning that when you do a scan from the receiver, it actually goes through a number of different booster ranges, so we can pick up whatever frequency range you want to work in, and then the receiver only sees that 24 megahertz that you can select from the filter. So that makes it also way easier and makes the system run more stable simply, because we're only looking at the spectrum we want to look at.